All right, so in this video, what we want to do is we want to find the indefinite integral of negative 9x squared times negative 3x to the third plus 1 all raised to the third power dx. So what we normally do is to let the inside function, and in this case, we're going to let this part equal to u in an effort to work this out. Another thing is we try to let the higher power take u so that when we differentiate, we're able to cancel because we really want to cancel, right? So let us let u equal to negative 3x to the third plus 1, right? So from this, we're going to find du dx. So du dx, remember the power rule. So 3 times negative 3, that's going to give me negative 9. And then we have x raised to the second because we're going to subtract 1 from the 3. What we have here is a constant, and the derivative of that is 0, right? All right. So we want to find dx. So we're going to switch these out, these two out. So du over negative 9x squared is equal to dx. At some point in time, we're going to replace that dx right there. All right. So let us take a look at what we have. What we really have is negative 9x squared. This is u. Remember, so this is u raised to the third. And then we have dx, but instead of writing dx, I'm going to replace the dx with u over negative 9x squared. From this, you're definitely seeing where we are able to cancel this negative 9x squared with this. So let us take a closer look. What we really have is actually u raised to the third du. So at this point in time, because everything is now represented in u, we're going to take the integral of u to the third du. So remember, we're going to add 1 to that. So it becomes u to the fourth, then divide by the new power over 4, plus our constant of integration, which is c. Now, please be reminded that we had substituted early right here that u is equal to negative 3x to the third plus 1. So my final response is going to equal to negative 3x to the third plus 1. And I'm going to raise that to the fourth over 4 plus c. So for this question, again, we're going to let the inside function, which is 3x to the fourth plus 3, which is this, we're going to let that equal to u. So u is equal to 3x raised to the fourth plus 3. Let's find du dx. So du dx is going to equal to 12, 4 3 is 12, x raised to the third, and this is a constant, so that's a 0. Now, we want to make sure that we have dx as a subject. So dx is really equal to du divided by 12x to the third. So we simply just switch these around right there. All right, so let us see what we have. What we really have is that the indefinite integral of 36x to the third, and remember this is now u raised to the fifth, and I'm going to replace dx with du over 12x to the third. The moment I do that, I do realize that 12x to the third could go into 36x to the third 3 times. So let us rewrite what we have. I have 3 u raised to the fifth du. Because everything is now expressed in terms of u, I'm now able to integrate. So let us go ahead. Is we could actually put the 3 on the outside there. So we're going to have u to the fifth du. So let us integrate this right now. So basically, I'm going to have 3. And then what I really have is u to the 6 over 6, right? Plus c. At this moment, the 3 and the 6 could cancel. So I'm going to have a half, right? U to the 6 plus c. Remember that c is actually 3x to the fourth plus 3. So my final response is a half 3x raised to the fourth plus 3, right? And then I'm going to add my constant of integration. This is my final response right here. Again, we're taking the integral of x into 4x minus 1 raised to the fourth power dx. The idea that we're going to do here, we're going to do u substitution. So we're going to let u equal to 4x minus 1. So let us start here. U is equal to 4x minus 1. All right, so by that, we can take du dx. So du dx is going to equal to 4. This becomes a 0. Now, what is dx? Dx, if I should switch these out right there, du over 4 is equal to dx. Let us rewrite this. So this is the integral of x, and then we have u raised to the fourth, and my dx will now be switched out for du over 4. After doing all of that, we were not able to get rid of that x. So we're going to come back here, and we're going to take this, and we're going to let x be the subject. So u is equal to 4x minus 1. Transposing for x, u plus 1, adding 1 to both sides, as you could see, is equal to 4x, then dividing by 4, divided by 4. So in this case, we're going to replace x. So u plus 1 over 4 is equal to x. I'm going to put that where x is. So let us rewrite this. So instead of writing x, I'm going to write u plus 1 over 4. And this is going to multiply by u to the fourth over 4 du. All right. So with that said, we could just simply clear this up quickly. I'm going to distribute my u to the fourth inside. So basically, if I distribute, this is a binomial basically. So I'm going to have u to the fifth plus u to the fourth. All of this is going to be over 16, but so this is over 16 du, right? Move that 116 on the outside. So we have u to the fifth plus u to the fourth du. All right, so now we could take the integral of that. So let us deal with that. So in doing so, what we really have is that we're going to have, say, 116 right there. So in here, I'm going to actually have u to the sixth over 6 plus u to the fifth over 5 right there, right? And then plus a c. Remember what u is that we're going to switch these out. So we have 116. Let's switch back the u. Remember, u was equal to 4x minus 1. So this is 4x minus 1 raised to the sixth. And remember that this is over, I'm going to put a big bracket. This is over 6 plus 4x minus 1. This is going to raise to the fifth, and it is over 5. And then we have plus c here. Now, what we want to do is just to distribute our 1/16 inside, basically, to top it off. So basically, what we have here is 1 over 96, 4x minus 1 raised to the 6. Then we actually have 1 over 80. And then we have 4x minus 1 raised to the fifth plus c. And there it is. This is my integral.